Okay, welcome back to the learning video for your preparation of SE review. So in these questions, we have the simultaneous equations problem. Here we have the line equation that is 3x minus y equals to 5. That is intersect the two lines satisfying the equations of the absolute value x minus y equals to 2 at the points P and Q. Now, to solve this one, we need to write down the equation that is 3x minus y equals to 5 as our first equation for the simultaneous equations. Okay, and for the second and the third equations, they come from this absolute value. We know that this absolute value has two meanings. The first meaning is positive x minus y equals to 2, and the second meaning is minus x minus y equals to 2. Okay, so simplify the second one, we'll get minus x plus y equals to 2. So this these are our second and third equation. So we can write down x minus y equals to 2 as the second equation and minus x plus y equals to 2 as the third equation. Now, to solve this problem, we can use the elimination and substitution method, and we start from the equation 1 and 2. Okay, so write down the equation 3x minus y equals to 5, and then x minus y equals to 2. In this step, you need to choose which variable that you want to eliminate. I think the easier way to do this is the variable y. So I will put the negative sign here, and 3x minus x is 2x, minus y minus minus y is cancelled out. Now, for the constants, 5 minus 2 is 3. So, the variable x is 3 half. To find the variable y, I will use the substitution method and choosing the equation 2. Now, write down here the 3 half minus y equals to 2, and then we get y equals to 3 half minus 2, that is minus 1 half. So we have the values of x and y, so we get the point P. Actually, you don't worry about the name of the point, P or Q, it doesn't matter. So in this case, I just use P. Okay, P is 3 half, comma, minus 1 half. Next, we can go to the second way. Here we have the equation 1 and 3. Alright, so I write down here 3x minus y equals to 5 and minus x plus y equals to 2. And then I want to eliminate the variable of y. I'll choose the positive sign. So 3x plus minus x is 2x, minus y plus y is cancelled out, and 5 plus 2 is 7. So the variable x in this case is 7 half. To find the variable y, I will choose the equation 3. It's easier than using equation 1, right? So I get minus 7 half plus y equals to 2, or y equals to 2 plus 7 half. Now, solving this one, we'll get 11 half. Okay, so that is our point Q with the coordinate 7 half, comma 11 half. All right, now let's go to the second questions. Here we have to show the point R1, comma 3 lies on the perpendicular bisector of the line PQ. So to solve this one, you need to know our coordinate of points P, and Q. If we connect this dot, we'll have the line or the segment line PQ. And the bisector, the perpendicular bisector, is the line that lies on the mid of the point PQ. So let's say the midpoint of PQ is M, and this R must be shown lays down on this perpendicular bisector. Okay, so that is the idea how to uh, show for the equations part 2. Now to do first, I think we need to find the coordinate of M. So the coordinate of this midpoint M is formulated by xp plus xq over 2, comma, yp plus yq over 2. Okay, so xp must be here. Okay, this is our yp, this is our xq, this is our yq. All right, so you just substitute the value here. Xp is 3 half, xq is 7 half over 2, comma, yp is 1 half, yq is 11 half over 2. Okay, so solving this one, you will get 5 half, comma, 5 half. So that is our midpoint. So the idea is you need to show the segment PQ and the segment MR is perpendicular. To show that, you need to show the gradient of PQ times the gradient of MR must be equal to minus 1. So that is our goal to show this question. Okay, so first of all, you need to find the gradient of MPQ. So the formula, the gradient is YQ minus YP over XQ minus XP. Now substitute the YQ here is 11 half minus YP is minus 1 half over XQ 7 half minus the XP that is 3 half. Now we get 12 over 2 over 4 half. Alright, so we can write down, we can arrange this division becomes 12 half times 2 over 4. Simplify this one, we will get 3. Okay, so the gradient PQ is 3. And then we can continue for the gradient of MR, that is YR minus YM over XR minus XM. Okay, so here our XR on here, YR on here. Okay, so substitute, sorry, that is our XM and YM. For the XR here and YR here. Okay, substitute the value XR, YR, XM, YM. So YR is 3 minus YM is 5 half over XR is 1 and then XM is 5 half. Okay, simplify this one, you will get 1 half over, here we have 1 minus 5 over 2, 3 half minus 5 half. Let's say, let me check it. 5 to, yes, we get minus 3 half. And if we simplify this one, we get 1 half times minus 2 third. Okay, you can cancel out the 2 here, and then you get minus 1 third. Now, let's prove we multiply both of these gradient m of PQ times m of MR is equal to 3 times 1 minus 1/3, and we'll get minus 1. So the conclusion here, we can say that the point R 1 comma 3 lies on the perpendicular bisector of the line PQ. So don't forget to write down the QED to show that you have proven the questions is true. Okay, so that's all for this example. I hope you can understand, learn from this video, and good luck for your SE. Thank you.